Hey, it's Mr. Barr, and these are the notes for solving systems of linear inequalities. Let's get going here. Learning goal: I can create and use linear inequalities and graphs to model real-life situations. Why? Life is rarely equal. I want to be able to use the concept of greater than and less than to solve problems. Okay. So you have $12 to spend at the snack bar. Sodas cost $1, candy costs 75 cents. You do not have to spend all your money, but you did promise your 3 friends that you would buy them at least 1 soda. Welcome to the world of systems of linear inequalities. This system can be modeled with the following equations. It's going to take 2 equations to make this happen. So this first equation is the cost of a candy bar times the number of candy bars plus the cost of a soda times the number of sodas has to be less than or equal to $12 because that's all the money I have. But the number of sodas has to be greater than or equal to 3 because I promised each of my friends a soda. Notice it takes 2 equations. Can we graph this? We absolutely can. And that's what we're going to do today. So let's start with our notes with our name. Our title is Solving Systems of Linear Inequalities. And the question is, what is a system? And the answer is, a system is 2 or more things working together. A linear system is 2 or more lines on the same graph, and we've already covered linear systems at this point, I think, have we? Actually, we haven't yet. So a linear system is 2 or more lines on the same graph, and a system of linear inequalities is 2 or more linear inequalities on the same graph. So let's get that into our notes. A system of linear inequalities is 2 or more linear inequalities on the same graph. A system of linear inequalities is 2 or more linear inequalities on the same graph. What does this look like? Coordinate system. A line, I went with a dashed line on that one. Another line, I went with a solid line on that one. And then a shaded region This is a system of linear inequalities. In the last lesson, you just did 1 line and you shaded. This one, it's going to be 2 lines, and then you're going to shade 1 of those areas. So how do you show the solution to a linear inequality? It's the shaded region. So everything in this region works. Everything over here doesn't work. This is the region where it works in both of the inequalities. Points in the shaded region are the solutions to the inequality. These are the solutions. We already know about solid and dashed lines because we did that in the last set of notes. The solution also includes points not on the line, so you need to shade the region. So if you see here, it actually broke it into 4 regions. 1 region, 2, 3, 4 regions. And one of these regions is the solution region, where every point in here works within the system. This one I'm going to do on the screen, and then we'll get some stuff into the notes. So I have this first equation, and it starts at 1, and then it goes down 1 over 2, down 1 over 2. And it's dashed, right? And where would I shade? Well, in this one, I would shade, let's see, 0 is less than 0 plus 1. 0 is less than 1, so I'd shade underneath this thing. This is the last lesson we did. This one, I start at -1. I go down 3, 1, 2, 3 over 4, 1, 2, 3, 4. Also a dashed line. And this one, let's test 0, 0. 0 is greater than -1. That's true, so I shade above this line. Now imagine that we take these two graphs and we mush them together. Imagine that I take this graph right here and I bring it on top of this graph right here. You with me? I'm going to do it in another color. So I'm going to take this one over here and I'm going to put it on top of this one. Okay. I start at 1 and I go down 1 over 2. And I shade underneath this one, right? But on the other one, this one I'm actually shading above it. So this is the region in between the two lines. This is where it all works. These are the points that work in both inequalities. This is the solution. So I shade below the blue, I shade above the red, and when I put them together, if I mush them together, I get this region right here, and these are the points that work in both of the inequalities. It's the overlapping region where everything works. Over here, it works in only the red, here it works in only the blue, but here it works in the red and the blue. All the points in the overlapping area are the solutions. Imagine a door with 2 locks. You have to be able to unlock both of the locks to get in. So the red region only unlocks the top lock. The blue region only unlocks the bottom lock, but the red-blue region unlocks both of the locks. We have to unlock both of the inequalities. All right, this one, what else going to do, and then we'll make a flow map. Okay, so let's graph this. So this is a mini-me equation. So I have 2x equals 8, 4y equals 8, x equals 4, y equals 2. X equals 4, y equals 2. It is a solid line. And Where do I shade? Well, I'm going to test 0, 0. Let's test 0, 0. 0 plus 0 is less than 8. 0, 0 is less than 8. So I'm going to shade over here. But instead of shading it right away, I'm just going to put some little arrows to remind me to shade underneath this line. Let's go do the red graph now. This is a slope-intercept equation. I'll start at 2. And I'll go up 1 over 2, up 1 over 2, and I'll draw a line. I'll test 0, 0 and see if it's true or false. 0 is, ooh, you know what? This should have been a dashed line, right? Sorry, my bad. Dashed, dashed. Okay, so that's a dashed line. 0 is greater than 0 plus 2. 0 is greater than 2. That is false. This point is false with regard to the red line, which means I need to shade above the red line. So where do the two shaded regions come together? Do they come together over here? No, nothing works over here. Do they work over here? Only the red works here. Does it work here? Only the blue works here, but this is the region where it all comes together. This is the solution right in here. So this is me doing it again. And there's the region where it all comes together. Similar idea. X. Oh, let me do blue. (3x) equals 6, negative y equals 6, x equals 2, y equals negative 6, x equals 2, y equals negative 6, 1, 2, 3, 4, 5, 6. That's going to be a dashed line. Although, to make my life easier, I'm just going to draw it as a solid and then I'll dash it right now. It's really dashed. Next one is a slope-intercept equation. Going to start at negative 3. Going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. This is a solid line. And I'm actually doing this out of order. I should have tested that blue line. So let's go test the blue. Blue at 0, 0, 0. Minus 0 is less than 6. For blue, 0 is true. This is true for blue, so I'm going to shade on this side of the blue. Let's test the red. 0 is less than or equal to 0 minus 3. 0 is less than or equal to negative 3. 0 is less than negative 3. That is false. So this point is false with the red, which means I'm going to shade under the red. So I want to be on top of the blue, but under the red, which means all of this is the area that works. On top of the blue, under the red, that's the area that works. Let's do this one. This is just y equals 1 over 1 x plus 0. So I have a line that's coming through like this. And it's dashed. Let's test it. I can't test 0, 0 because it's on the line, but I can test, let's see, I can test 0, I can test 1 comma 0. Let's test this point right here. 1 comma 0. 1. 0 is less than 1. That is true. This point is true, which means I'm going to shade under the blue line. Ooh, x equals 0. Well, what's x equals 1? X equals 1 would be this line right here. So x equals 0 is this line right here. It's actually the y-axis. And once again, I can't test 0, 0, but you know what I could test is, let's test 1, 0 again. Let's test 1, 0. 1 is greater than 0. That's true. So this point is true with regard to the red line. So I need to be under the blue and to the right of the red. So it's this region right here. All right, so let's do a quick flow map. So how should we do these? So we'll call this graphing linear inequalities. Okay. Here's how we're going to do it. Graph the first line. Here's how we're going to do it. We're going to use a marker that actually writes. Graph the first line. Test a point. Show shading. With little arrows. So graph your first line, test a point, show shading with little arrows. Graph second line. Test a point. Show shading. With little arrows. So now use those little arrows to do the final shading. All right, those are the notes for this one. I know that's a long lesson. That was 20 minutes worth of stuff. Speed it up on YouTube. All right, thanks for watching. Have a great day.